All right, so section 3.1 is on solving systems of equations by graphing. So a system of equations is basically having a set of equations containing two or more variables. Guys. So let's say we have like two equations that have x and y. Then you can solve for x and y. So what you learned in Algebra 1 is you can do substitution or elimination. You can also do this method we're going to do today, which is graphing. Okay, a linear system is when these are both lines. So you could have like a parabola intersecting a line. That would not be a linear system. One of them would be a line. Okay, so first we're just going to do the basics. So it says use substitution to determine if 1, -2 is an element of the solution set. So if it's going to be an element of the solution set, that means it's going to work in the equation. So we're going to plug in 1, -2. So I have -2 is my y, 1 is my x. I want to see if it makes the equation true. So I usually put it like a little question mark above it. So is -2 equal to 2 times 1 plus 1? So I have -2. I'm seeing if that's equal to, this would be 2 plus 1, so it's 3. So that doesn't work, right? So -2 is not equal to 3. So it's not a solution. It's not an element of the solution set. All right, so same thing for this. So I'm going to have y equals 3 times x minus 5. So y is -2. I'm seeing if that's equal to 3 times 1 minus 5. So now I have -2 equals -2. That does work. So yes, it's a solution. All right, so what that means is that point is on the line. Those were both just lines of saying that the point is on the line. Now, if you have two lines, you could have one point on both of the lines, right? If they intersect, it's an intersection 1 point, like that, right? Or you could have the two lines on top of each other. So it's the same line, and then there's an infinite number of points that would be on that. So you could have an infinite number of solutions or just one solution. So it says use substitution to determine if -2 is an element of the solution set. So now we have to check it in both of them. So I'm going to check it in x plus y equals 0, and I'm going to check in 7y minus 14x equals 42. So I'm going to plug in -2, 2. So -2 plus 2, is that equal to 0? That works. All right, and then I'm going to try -2, 2. Now be careful, the 2 is the y, the -2 is the x, so put them in the right spot. See if that's equal to 42. So you get 14 plus 28. Is that equal to 42? Yeah. So it works. So like I said, what this means is the point -2, 2 is on both of those lines. Okay? Yeah.
So the solution set both.
Yep. All right, so it says use a graph to solve the system. So if I have 2x minus 3y equals 3, and I have y plus 2 equals x. Okay, I'm going to solve both of them for y. Okay, so the bottom one's really easy to solve for y. You just get y equals, track the 2 over, so x minus 2. Okay, the top one's a little bit harder. Okay, so when I do that, I have 2x minus 3y equals 3. I want to subtract the 2x over, so -3y equals -2x plus 3. And divide by -3. Now, some of you guys on your test are messing this up. -2 divided by -3 is positive 2/3, right? Some of you are forgetting. And then it's going to be positive 3 divided by -3 is -1, right? We're going to graph both. Now, some people like to color code these problems. It's up to you. So let's say I draw this first one in black, and I'm going to draw the next one in blue. All right, so the first one's going to be y equals x minus 2. So the y-intercept is -2, so go down 2. That's where you start. You always need the starting point. And your slope is 1, so you're going to go up 1, right 1, up 1, right 1, up 1, right 1. All right, and then use a ruler. So if you don't have a ruler, I can pass them around and draw your line in. All right, the reason I say use a ruler is because sometimes it's a little bit hard, and sometimes you can't really tell where it's crossing. I'm going to try to use a ruler too. So I got that. See, mine still didn't look good. All right, and then I have, the other one is 2/3 x minus 1. So I'm going to go down to -1. Oops. So down to -1, and I'm going to draw that one as well. So I'm going to go up 1, 2 over 1, up 1, 2, sorry, not over 1, up 1, 2 over 3, right? 1, 2 over, my first line is just so terrible, I can't even tell. So negative 2. Hopefully your lines are nicer. All right, so at negative 1, I'm going to go up 1, 2 over 1, 2, 3. It looks like it's crossing at that point right there. So it's going to be 3, 1. All right, so that is your answer. So your answer is 3, 1. So make sure on your homework you don't just draw the lines and then don't say the answer. The solution to that system is the point 3, 1. So same thing on this one. So use a graph to graph the system. So we have y plus 2 equals, is it 3x? Mine's covered up. Move it. Yeah. Okay, so then I'm going to have y equals 3x minus 2. So go down to negative 2. And go up 3, right 1. So up 1, 2, 3, right 1. And you can do it a couple times. 1, 2, 3, right 1. You can do it down and left as well, as long as in the end you have a positive slope. So down 1, 2, 3, left 1. So we get that. All right, and then the other one is x plus y plus 6 equals 0. So y equals negative x minus 6. So go down to negative 6. So 3, 4, 5, 6. And you're going to have a slope of negative 1. So go down 1, right 1. Or you could go up 1, left 1, which is convenient in this problem. You guys see? So it looks like it's intersecting at negative 1, 5. Negative 5. So negative 1, negative 5. That's your answer. Okay, if you weren't sure, so if you don't use a ruler, these can be disastrous, right? Because your lines can be a little wobbly and you're like, oh, I think maybe it's negative 1, negative 4. All right, but if you're not sure, always check in your original. So if I plug into the original, so I had y plus 2 equals 3x. If I plug in negative 1, I get, or negative 5 for y, negative 1 for x. I get negative 5 plus 2 equals negative 3. That works, right? And then check in the second one as well. So I have negative 1 plus negative 5 plus 6. Well, that makes 0, so it works. So you can always quickly check. All right, next one. Okay, so it says a consistent system. Okay, this is the thing that may be different from Algebra 1. Maybe you haven't heard these words before. So a consistent system is a set of equations that has at least one answer. So there's an answer. So consistent means there's an answer. All right, inconsistent. If you kind of think like what the words in English mean, if something's inconsistent, maybe it worked one time and then it didn't work all of a sudden, right? So an inconsistent system is one where there's no solution. Okay, so there's not going to be a solution. So first you're deciding, is there an answer or is there not an answer? If there's an answer, that breaks into two things. So a consistent system could be dependent or independent. Okay, so if it's inconsistent, it is only inconsistent. All right, so let's try these on the next one. Okay, so it says solve the system by graphing. So I have x minus y equals 4. Okay. So I'm going to subtract the 4 over. I'm going to add the y over. I get y equals x minus 4. So go down 1, 2, 3, 4. Your slope is 1, so up 1, right 1. The other one's pretty easy to solve for y. So you get y equals negative 2x plus 5. So go up to 5. Okay, and your slope is negative 2, so go down 1, right 1. So just as long as you're going down into the right, right? So you read it like a book, left to right. Yeah, so draw your line in and see where it intersects. do next Thursday. All right, so draw it in. Where'd you guys get it intersecting? Oh, I totally missed it. I think I got like 3, -1. Did you guys get that? 3, -1. All right, and if you check quickly, it does work in both of them. So 3 minus a -1 gives you 4. 6 minus 1 gives you 5, right? All right, so that's your solution. Okay, so now we decide. So there is an answer, so it's consistent. Okay, so from there, I decide if it's independent or dependent. So I haven't told you what those are. So if you go back, it says a dependent system is a system that has infinitely many solutions. And an independent system is a system that has exactly one solution. So a dependent is going to be where you have one line and then you have another line right on top of it. They're the same line. And independent is going to be where they cross, right, in one spot. All right, so is this dependent or independent? And that's the one that people usually mess up on. Okay, so independent. All right, so let's sketch out the next one. So I have 2x minus 4y equals 8, and I have x minus 2y equals -7. So you could use your x-intercept, y-intercept method, set up that way. Or you could solve for y. On these, I like to solve for y so I can see if the slope's the same or if they're different or whatever. All right, so if I have 2x minus 4y equals 8, I'm going to solve for y. So I'm going to subtract the 2x over. I'm going to divide by -4. So I get y equals positive 1/2 x minus 2. So I'm going to go down to -2, and my slope is 1/2. So I'm going to go up 1, right 2. Up 1, right 2. It's looking like that. Now the second line, I have x minus 2y equals -7. So I'm going to subtract my x over, and now I divide by -2. So I get y equals, I had -1 divided by -2, so it's 1/2, positive 1/2. -7 divided by -2, that's -7 over 2, or it's positive 7 over 2, right? Or plus 3.5. Doesn't matter. Okay, so we're going to go up to 3.5. So 1, 2, 3.5. And then it's always hard doing the slope of 1/2 from there. As you're going up 1, you're going in between the spaces, right? So up 1, right 2. But you should be kind of thinking, oh, there's something strange about this problem. What do you guys notice? They're parallel because you had a slope of 1/2 here and you had a slope of 1/2 here. We know they're not the same line because their y-intercept was different. So they're going to be parallel lines. They're not going to be the same line. So there's going to be no solution. Now, when we get a no solution, we go ahead and we just say it's an inconsistent system. Right? Something wasn't working in that to give us no solution. It's inconsistent. From there, we don't say dependent or independent. It's just inconsistent. Yeah.
So when we say inconsistent when it's not a match, it seems like it could happen sometimes, but
yeah, so an inconsistent is where maybe like y in math, why would that be called inconsistent? Sometimes in math you get a solution, like you might get a solution, but if you go back and you check it, it doesn't work. Now in these problems that's not going to happen, but sometimes you have what we call them extraneous solutions, where you get an answer, but then if you check it in the original, it's not going to work out. So that's probably why they call it inconsistent. All right, number 3, so solve the system by graphing. So we have the first one, so y equals 2x plus 3. So I'm going to go up 3. And my slope is 2, so up 2, right 1, up 2, right 1. Oops, it went up 3, I think. Up 2, right 1. We get that. Okay, and the next one, we have 4x minus 2y equals -6. Okay, so let's solve that one for y. So I'm going to have 4x minus 2y equals -6. So I'm going to subtract the 4x over and divide by -2. So you end up with y equals 2x plus 3. What do you notice?
It's the same one.
Yeah, same line. So if you draw that line, it's actually on top of the other line. They're the same thing. All right, so that means that every single point will be a solution of both of them. So every single point on that line will be a solution of both of them. So like 0, 3 works in both. 1, 5 works in both of them. Okay. All right, so we say that it's consistent because there is an answer. There's actually infinitely many, so we call it dependent. Okay, and I'm not going to make you do this in Algebra 2, but here's why we call it dependent. Later on, when you get into other math classes, we write the solution. Okay, so the solution is going to look like this. So for some t, we usually use t, your y value that goes with it is 2t plus 3. So any point in the form t and then 2t plus 3 will be a solution. So if you plug in 0, you get 0, 3. If you plug in 1, you get 1, 5. If you plug in 2, you get 2, 7. Do you guys understand? So all of those things are solutions. You could even plug in 1/2. Right? If you plug in 1/2, you get 1/2. 1/2 times 2 is 1 plus 3, so 4. Right? All of these things would be solutions. What did I say? 1, 5. Right? So anything in that form will be a solution. So it depends on what t is. So that's why it's called dependent, because it depends on what your t value is on what the y value is. Okay? So that's why it's dependent. All right, so here's a little graph for you. So it says if the lines are different and intersect, the equations are called independent, and the system is consistent. If they're different in parallel, we just call it inconsistent. And if they're the same thing, the system is consistent, but they're called dependent equations. Okay, so a lot of times I'll have that little cheat sheet for you. Like on your homework, I have that little box there for you. So you can kind of remember what each one is. All right, we're going to go ahead and do 3.2 today as well. So 3.2 is on solving systems of equations algebraically. All right, do you guys remember the substitution and elimination? Do you guys remember these words that I'm speaking? Maybe. All right, so substitution is a method in which you solve for one variable in one of the equations and you substitute into the other variable. All right, so I have the steps there. You can read through if you want, but I'll just show you an example. So the first one, I have y equals x, and then I have x plus y equals 4. So the goal is to get it to be just one equation. Okay? So if I have y is equal to x, then in the second equation, I can replace my y with x. So I'm just putting it in. So that means I'm going to have x plus x equals 4. So 2x equals 4. So that means x is 2. And then once you have one of them, then you can find the other one, right? So you plug into any equation, so y equals x. If x is 2, then y is also 2. So what this means is you had two lines that intersected in a point. They intersected in the point 2, 2. So that's your answer. Now I caution you with this section. This homework is always like the worst homework that I grade. It's terrible because you guys mess up the first one and then therefore you mess up the second one. So it's always good to check these. So step 4, it says check your solution. So check them in both. 2 equals 2, 2 plus 2 equals 4, right? So it works. That can save you multiple points in your homework by just doing that step. All right, so the next one. So I have x minus y equals -4, and I have 3x minus 2y equals -5. So what's a variable that's really easy to get by itself? Yeah, the x in the first equation. Do you guys see that? Don't overcomplicate things. Don't use the second equation and then all of a sudden have fractions. Right? Make it as easy as possible. So the first one is very easy to solve for x. So you get x equals, if you add the y over, you get y minus 4. So once you have one of the variables by itself, so if you have x or y by itself, so we had x, we're going to replace that x with y minus 4. So you're going to have 3 times y minus 4 minus 2y equals -5. So 3y minus 12 minus 2y equals -5. Tyler, you paying attention? Add, so 1y minus 12 equals -5. Add the 12 over, you get y equals 7. That's where people mess up. They're always like, oh, -17. right? You gotta be careful. All right, now plug 7 in. So I have x minus y equals -4. So y is 7, so x minus 7 equals -4. Add the 7 over, and you get x equals 3. So your point is 3 for x, 7 for y, 3, 7. Always write it as a point in the end. It makes it really easy for me to grade. If I'm searching for your x and y, I just get angry. You don't want me angry when I'm grading your homework. All right, so the next one, so I have x minus 5 equals 3 over 2y, and I have 2x minus 3y equals 8. Okay, so one of the variables is really easy to get by itself. It looks like x is. Yeah, you're all over that. So I get x equals 3 over 2, y plus 5. Yes, there's a fraction. I think we'll be all right. We can handle it. All right, so I'm going to replace my x with 3 over 2y plus 5. All right, so I get 2 times 3 over 2y plus 5 minus 3y equals 8. Do you see why I said it was okay that we had a fraction? Multiply your 2n. So 2 times 3 over 2 gives you 3. So you get 3y plus 10 minus 3y equals 8. So 3y minus 3y is 0, so 10 equals 8. What do I write? No solution, right? So if that happens, it's no solution. But if you had gotten like 8 equals 8, or 10 equals 10, or 0 equals 0, that works, right? That's a true statement. So if you get like 0 equals 0, we write infinitely many solutions, because that's an example where they would be the same line. Yeah. So Carrington says, if it's infinitely many solutions, should you do negative infinity to infinity? I would accept that. I'd accept the fancy R. I'd accept all real numbers, or infinitely many solutions. Really, I think the best way to say it would be infinitely many solutions, right? Because it's points, it's not really like numbers. So I think the best way would be infinitely many solutions. Because it's like 2, 1 doesn't necessarily work in it, but there is a point for x equals 2 that works. But 2, 1 or 2, 2 may not work. All right, so steps to the elimination method. So sometimes people will call this the addition method. So if you've heard that, same thing. So it says write both equations in standard form. In other words, in the form ax plus by equals c. Okay. Multiply the terms of one or both the equations by constants so that the coefficients are opposite one another. So let's say the x values, one of them had 2x, the other one needs to be negative 2x. Or if you were getting rid of the y's, if you had 5y, you need negative 5y. All right, 3, line up the two equations and add straight down. So add straight down. Solve the resulting equation if possible. So you're going to add, and that's going to eliminate a variable. Then plug the number you found into either of the original equations and solve for the remaining variable. And then, like before, we check. Just because if you mess up one of these, you're going to mess up both of the points. And I do that on your test a lot, where if you mess up the x, and then you mess up the y as well, you're missing multiple points, right? So you always want to check. All right, so this first one, I have x minus y equals 3, and I have x plus y equals 7. So they're already in the standard form. All right, so I always check to see if what happens if I add straight down. So if I add straight down, I'm getting 2x. Do you see the y's go away? And then I get 10. So this is one that's already set up for me. I'm going to add straight down. I get 2x. The y's go away equals 10. So I can find x right away. X is 5. So once you have x, plug it into either equation. So 5 plus y equals 7. You should get y equals 2. So you have the point 5, 2. So that was an easy one. You could just add straight down already. Okay, this next one's a little bit harder because now you have 3x and 2x, and you have 5y and 3y. There's no way to get rid of your variables if you just add straight down, right? So you need to multiply by something. So I usually do like whatever's going to give me the smallest numbers or whatever's easiest. So in this case, you actually have to multiply both equations, right? So I'm going to multiply the top equation. Let's get rid of the x's. Let's multiply by 2 on the top equation. And then I want my x's to be opposite each other. So right now I'm going to have 6x. So I want the bottom one to be negative 6x. So let's do negative 3. Okay, so the top equation becomes 6x plus 10y equals negative 32. Don't forget to multiply on the right side as well, to the number. That's a big error that I'll see on the test. A lot of people forget that. And then you get negative 6x minus 9y equals 27. So now they're set up so the x variables have opposite coefficients. So add straight down. So x's go away. Y's go away. You get negative 5. Plug back into any equation that has x and y. I usually go with the original one because they have the smallest numbers. So 2x plus 3 times negative 5 equals negative 9. So I'm plugging into the second equation. So I get 2x minus 15 equals negative 9. Add 15. So I get 2x equals 6. So x is 3. So you have 3 for x, negative 5 for y. So that's your answer. All right, so let's do the next one. So this one you don't have to do both equations. You could multiply by 3 and negative 5 to get rid of the x's, but what's easier in this case? Yeah. Yeah, if you only have to do one multiplication step, I would do it that way. So like you could get rid of the y's. All you need to do is multiply the top one by 2. So you're going to get 10x minus 4y equals 38. And on the bottom, you still have the 3x plus 4y equals 1. So now when you add straight down, you get 13x. The y's go away, equals 39. So you get x equals 3. Plug back in. So 5 times 3 minus 2 times y equals 19. So 15 minus 2y equals 19. Subtract the 15. So negative 2y equals, subtract 15, so 4. So y equals negative 2. So you get 3 comma negative 2 for your answer. Okay, back when you were in Algebra 1, you might have done what some call the subtraction method. You guys know what I'm talking about? Where you get the same thing, but then you subtract out the bottom equation. I hate that method because you guys mess up your signs. So I always do the addition method. I make it so that they're opposite each other, so I just add straight down and they go away. So don't make them the same and then subtract. It gets confusing. All right, so solve the systems by any method. All right, so try number 1 and try number 2. 2 has fractions, so I'd probably go about clearing the fractions first. That might help. So let's try them. All right. So the first one, I would probably do the elimination method. So line them up. So add the 4y over, so 4x plus 4y equals 5. And that's usually the point when I can tell. Can you guys tell? Like, because you're like, oh, if I multiply the top equation by 2, then you're going to get 4x plus 4y equals negative 2. But then below it, it said 4x plus 4y equals 5, right? So 4x plus 4y can't be negative 2 and 5. So that's when I know it's no solution. So let's go ahead and do the method. So multiply by negative 2. So this would be a negative. Plus, so when you add straight down, they go away, and you get 0 equals 7. Okay, so that's no solution. All right, now the next one, I was saying it's easiest if you clear the fractions first, because the fractions can be a little intimidating. So I'm going to multiply by 12. Some of you are still having trouble with this method, so if you're having trouble, make sure you're paying attention to how to do this.
How do you pick 12?
I knew that if I was going to make all the denominators the same, like if I was going to get common denominators, I had 4 and 3, so I would change them all to 12. So that's how I use that. All right, so I'm going to multiply the 12 into each thing. So off to the side, if you need to do 12 times 3/4 and 12 times 2/3, that's fine. You can think of it as 12 over 1, right? You get 36 over 4, which is 9. Or you can remember you're reducing, right? So 12 and 4 make 3. 3 times 3 is 9. You can do it that way as well, which I prefer if you have really big fractions. All right, 12 and 3 reduce to 4, so 4 times 2 is 8. So that one's going to be 8. So you get 12 times 3/4 gave you 9, so 9x. 12 times 2/3 gave you 8, so 8y. And don't forget the 12 times 7. 12 times 7 is 84. Some of you guys didn't learn your times tables up to 12 either. It's never too late to learn those. We'll help you on things like the SAT, ACT to quickly know those. All right, the next one. So now you have 3/5 x minus 1/2 y equals 18. So think, what would your denominator be if you were getting common denominators? So it would be 10, right? Because you have 5 and 2. Okay, so you're going to multiply each thing by 10. So off to the side, if you need to do 10 times 3/5 and 10 times negative 1/2, you can do that. So 10 times 3/5 is 30 over 5, which is 6. So you're going to get 6x minus 5y equals 180. Darn, I was hoping that they would end up being the same. They're not. Okay, so we can go even bigger. So let's try to change the 9 and 6 so that they have something in common. So, or that so that they're the same thing. So 18. You could do 1.5. So we did. What did that give you? Ah, that's not nice for the. Oh, like the bottom one by 1.5. Then you still have fractions though, right? So it's up to you. You could, like you're saying, 1.5 by the bottom one. That makes it 9. All right, so let's go ahead and make them 18 though. So we'll multiply the top one by 2 and the bottom one, let's make it negative, so negative 3. So I get 18x plus 16y equals 168. And then I get negative 18x plus 15y equals negative 540. So I get 31y equals, so 540 minus 168. You guys can help me out if you want. Did you guys already get this? 72? Is that right? Oh, 372. Just kidding. So 31 goes into negative 372 how many times? What do you got? You're going to make me do all this? The 12? 12?
Yes, 12.
Negative 12. So negative 12 is your y. So then you find your x. So your x is going to be, you can go back to the original or you can go back to one of these ones that doesn't have fractions if you want. So let's do 6 times x minus 5 times negative 12 equals 180. So 6x plus 60 equals 180. So 6x equals 120. So x equals 20. So your answer is 20 and negative 12 for y. So 20 comma negative 12. All right, is it break time? All right, you guys can go on break. Here we go. All right, so number 3, it says last year the soccer team paid $5 per pair of socks and $17 per pair of shorts for a total of $315. This year they spent $342 to buy the same number of pairs of socks and shorts because the socks now cost $6 a pair and the shorts cost $18. Write a system of 2 equations that represent the number of pairs of socks x and the shorts y bought each year. Okay, so if x is the number of pairs of socks that were bought, the first year they cost $5 per pair, so it's going to be 5x. And y is the number of shorts they bought, so it's going to be 17y. And it gave them a total of $315. All right, the second thing, they spent $6 a pair for socks and $18 for the shorts, so that gave them a total of $342. All right, you cannot add straight down right now because you have 5x, you have 6x, you have 17y, and 18y. So I'm guessing you want to make the x's the same because they're smaller numbers. So let's multiply the top one by 6 and the bottom one by negative 5. Help me out, be calculated out. Yeah, you can do fractions. I mean, if you're comfortable with fractions, you can go for it. All right, so we get 30x plus 6 times 17, so 34, what is it, like 102? Yep. 102y equals 6 times 315, so 1890. Check all my numbers. All right, so the negative 30x minus, is that 90y equals, oh goodness. Help me out with this one.
Negative.
1710, negative, right. All right, so add straight down, the 30s go away. You have 102 minus 90, so that's 12y equals 1890 minus 1710, so 180. So y equals? Okay, so y is equal to 15, so we find x. So we have 5, well, let's do this 6. That one seems nicer. 6x plus 18y equals 342. I guess in the original, you could have also like divided out by the common factor, which 6 goes in all of those, so you could have done that originally too. All right, so 6x plus 18 times 15 equals 342. So let's see, so 6x plus, what's 18 times 15? 270 equals 342. So subtract it out. What do we get? So 62? No, 72? All right, so x equals 12. So 12 pairs of socks, right, that was the x, 15 pairs of shorts. I don't know why they have more shorts than socks. Maybe people already had socks. Seems weird. All right, so the very last little bit in your notes, it says, oh, I guess we do have part B. So how many pairs of socks and shorts did the team buy each year? So I guess the first part was just writing the system. So it was writing this. So this is really part B. So part B was 12 pairs of socks, 15 pairs of shorts. Okay, so it says, notice in the previous problems we had an inconsistent system. So this happened when we had like 10 equals 8, 0 equals 5, right? A number equals another number. Okay, so on your homework, if that happens, we write no solution. All right, we've also seen a system with infinitely many solutions. This happened when 0 equals 0 or 10 equals 10, right? Something like that. -2 equals -2. So a number equals itself. So if you have that on your homework, write infinitely many solutions. All right, is that it? That's the end of 3-2. That was painless.